Hi everyone! In this video, we'll learn how to determine whether a probability distribution is valid, and then we'll practice finding probabilities from a distribution table. Let's begin with the rules that every discrete probability distribution must satisfy. Not every table of numbers represents a valid probability distribution. A discrete probability distribution must satisfy two conditions. First, the sum of all probabilities must equal 1. Why does it make sense? Because the table should account for all possible outcomes. If we add the probabilities of every possible outcome, we should get a total probability of 100%, which is equal to 1. The second condition is that every probability must be between 0 and 1, inclusive. This means probability cannot be negative and cannot be greater than 1. Whenever you're checking a probability distribution, always verify both conditions. Let's look at an example. Example 3. We're given this table and we want to know if this table is a probability distribution. We must check both conditions. First, we need to check if the sum of all probabilities equals 1. So we'll take 0.20 plus 0.35 plus 0.15 plus 0.30. And that equals 1. So the first condition is met. Next, we need to check the second condition. Are all probabilities between 0 and 1? So we are checking every single of the probability. Are they all in between 0 and 1? Yes. So the second condition is also met. Since both conditions are met, this table represents a valid probability distribution. Let's try another example. Example 4. We're given this table and we want to know if this table represents a probability distribution. Let's begin by finding the sum. We'll take 0.25 plus 0.40 plus negative 0.10 plus 0.45. And the sum equals 1. Now, let's check the second condition. Look at each of these probabilities. Are they all in between 0 and 1? Nope. This probability is negative. That's the problem. Probabilities cannot be negative. The first condition is met. The second condition is not. So this table is not a probability distribution. Why not? Because probabilities cannot be negative. Even though the probabilities add up to 1, all probabilities must also be between 0 and 1. Now, let's learn how to use a distribution table to calculate probabilities. When working with probability distributions, you often see probability statements that use symbols such as equals, less than, or greater than. Let's review what each expression means. P of x equals 3 means the probability that x is exactly 3. So x equals 3 means exactly 3. P of x less than 3 means the probability that x is less than 3. P of x less than or equal to 3 means the probability that x is less than or equal to 3, or 3 or fewer. P of x greater than 3 means the probability that x is greater than 3. P of x greater than or equal to 3 means the probability that x is at least 3. The key idea is that whenever an event includes multiple values, we add the probabilities for those values. Let's apply this idea. We're given this table, and we're told that this table is a probability distribution. These are the possible x values, and these are their corresponding probabilities. P of 0 equals 0.05. P of 1 equals 0.15. P of 2 equals 0.30. P of 3 equals 0.25. P of 4 is missing. It doesn't mean that they forgot to include P of 4 in. They just want you to find that value. So before we start answering any probability questions, we need to find the missing probability. Remember that all probabilities in a valid probability distribution must add up to 1. So let's add the probabilities that we know. We'll take 0.05 plus 0.15 plus 0.30 plus 0.25. We get 0.75. To find this missing probability, we'll take 1 minus 0.75, which equals 0.25. So this is the complete probability distribution. Now, let's answer the probability questions. Part A, find the probability of x equals 4. Look directly at the row where x equals 4. The probability is 0.25. Part B, find the probability that x is less than or equal to 2. The values less than or equal to 2 are 0, 1, and 2. Add their probabilities. So we'll take 0.05 plus 0.15 plus 0.30. Which equals 0.5. Part C, find the probability that x is greater than or equal to 3. The values greater than or equal to 3 are 3 and 4. Add their probabilities. So we'll take 0.25 plus 0.25, which equals 0.5. Part D, find the probability that x is less than 4. Values less than 4 are 0, 1, 2, and 3. Add the corresponding probabilities. So we'll take 0.05 plus 0.15 plus 0.30 plus 0.25. And that equals 0.75. There's another method to find P of x less than 4. Notice that the only value that's not less than 4 is 4 itself. Since the probability of all possible outcomes must equal 1, we can subtract the probability that x equals 4 from 1 to get the rest. So if you take 1 minus 0.25, you still get 0.75.